Okay, this is my last video of the series for today to kind of wrap up our introduction to the concept of a molar mass. So in the last video, we learned that we can calculate mass in grams or moles in moles if we know the molar mass of the substance. And we can get the molar mass if we know the formula of the substance. So again, just as an example, if I'm dealing with H2O, and that's one that I talked about at the end where we use it a lot, you might already have that memorized. There are 18 grams per mole. And I indicated to you that that unit grams over moles allows us to get the triangle that we can use in order to do calculations between grams and moles of a substance. And grams is on the top of the fraction, so I put the mass on the top, I put the moles on the bottom, and molar mass is what we call that other thing. That's what we call the property of that substance, the molar mass. We've already had an equation that already deals with moles, and that was our equation that dealt with entities. Now, at some point, you're going to have to memorize these triangles in order for you to do the problems. And as I stated to you before at the beginning of one of your tests, I said once the teacher says you can go and proceed with the test, you can write whatever you want on it. So if you memorize your triangles, as soon as the teacher says go, you can write them down. The entities equation had capital N for entities, because that's a big number of tiny things, a small n for moles, and it doesn't really matter which side the small n goes. I happen to put it on the left, but you could put it on the right to make it look like the other triangle. And the last thing that we needed was that special number, Avogadro's number, 6.02 times 10 to the 23 entities per mole. Again, notice I've been writing that unit entities per mole down a little bit. That was way back in that other lesson, but you could generate the equation triangle the same way that you generate the equation triangle for molar mass using those units. Remember, entities is our capital N, there it is there, and moles is our little n there. So there's very much a similarity between our triangles that we've learned so far. Okay, so essentially in these questions that I want to do quickly, I'm going to have to use two triangles, and the connection between the triangles is moles. And in chemistry, everything goes through moles. Moles are the way we deal with things. So when we're given a number, we're usually thinking about how many moles it is, unless we've been told how many moles it is. So let's find the number of entities in 5 grams of water. Even though I want to find entities and I'm starting with grams, you might think there's no way for me directly to get entities from grams, and that's true. So we need to have 2 steps. One step involving molar mass, and the other step involving Avogadro's number. In the last lesson, I suggested that you start making a map. I didn't have you make a map when we used entities, but we can. If I'm looking for entity, whoops, I don't want it to be red, I want it to be green. If I'm looking for entities, I can only get from entities by starting with moles. All right? And I can get from mass 2 moles, which means we will have 2 steps. The thing that allows me to go from mass to moles, we know is the molar mass, and I can build my triangle. And now I'm going to think about our entities triangle in the similar way as we did with our molar mass in my map. The thing I need to convert moles to entities is Avogadro's number. And Avogadro's number we know is 6.02 times 10 to the 23. I can, from the units of molar mass, grams per mole. This is entities per mole. And if you really want to put that N on the other side, you definitely can. It would make it look exactly the same. It doesn't matter. And they are the same. So now I'm going to do two steps. In the first step, it tells me I need a molar mass. I've already done that molar mass. Water, it's in the right-hand corner. I want to figure out what N is, because that's what I have as my first step. So I'm going to cover up the triangle. I'm going to cover up the N. N is equal to mass over molar mass. I have 5.0 grams, and the molar mass is 18.0 grams per mole. Pause for calculator finding. 5 divided by 18. 0.27777. There's only two significant digits in the 5.0. So I'm going to keep 7, 8. I'm going to keep a third one because I'm not done calculating yet. I've got one more calculation to do, so it's good to keep an extra digit. So I'm right here now in the middle of my map. I could even write this number 0.278 moles right there if I wanted to. I want to get entities. I'm covering up the big N, because that's what I want to find. Big N equals little n times Avogadro's number. 0.278 times, and I'm going to use brackets there instead, 6.02 times 10 to the 23 entities per mole. Again, I am not showing you my calculator. I did that the other day. I have my number in my calculator still, 0.27777 times 6.02 EXP. I don't press times nor 10. 23 equals 1.67 times 10 to the 23 entities of water. That actually should be rounded to 1.7 times 10 to the 23 because of the two significant digits in the 5.0 grams of water. Entities of water could be written as molecules, because that's what water is. But you know what? I'm fine if you just write it as entities. So there are questions that involve two steps. We make the maps and we complete them. Okay? One more. Come on, go forward. I'm clicking like crazy. Find the number of entities in, let me just check to see that that's the last one. Nope, we got a bunch of them. Let's jump ahead to this one. We've done enough. I'm jumping ahead to this one. Find the mass in grams of 2.25 times 10 to the 50 molecules of carbon dioxide. So you'll notice my screen is clear. I'm starting with molecules. Molecules is entities. I want to find the mass. There is no way for me to go from entities directly to mass. But I can go from entities to moles. And then from moles to mass. So like I said, in chemistry, everything goes through moles. Avogadro's number, molar mass. carbon dioxide. I need that molar mass. Avogadro's number, 6.02 times 10 to the 23. It's on our chart. You'll notice I calculated that fast. Carbon dioxide is another one of those molecules like water that we will see over and over again. I want to get N. Use your triangle. Using your EXP button properly will be very important for this. If you do not use it properly, you will not get it correct. I put that backwards compared to what we've been seeing. Doesn't matter. It's because I've kind of got it memorized. And I am running out of room. I'm going to squeeze that in there, 44.0 grams. And I apologize for the squishiness. I still have my previous number in the calculator, so I'm not going to clear it. All right. Yes, that's a large number of grams. Well, that's a large number of moles. We might even be talking about the number of grams of carbon dioxide in the entire atmosphere. I really don't know how big that number is. I'm just saying we could be dealing with big numbers. So in chemistry, sometimes we have really big objects like the atmosphere itself, lots and lots of mass. And sometimes we deal with really tiny numbers. Okay, so that last little video here that I just did gives you a couple of examples of how we can use our conversion, our equations together in order to determine entities or grams by going through moles. You now have the ability to complete that sheet all the way to the bottom that deals with this stuff. And again, the solutions are found in the PowerPoints, okay? All right, that's my last lesson in the group of 3 that deals with moles and molar mass.